Welcome back to Stellar Science, where we uncover the mysteries of the cosmos. Today, we embark on a celestial journey far beyond the asteroid belt and the swirling storms of Jupiter, past the glorious rings of Saturn and the icy realms of Uranus, to reach the outermost gas giant, Neptune. A world of deep blue, Neptune is the eighth and farthest known planet from the Sun in our solar system. It reigns over the outer reaches, a silent sentinel in the vast expanse of space. This gas giant, with its mysterious deep blue atmosphere and wild, high-speed winds, holds secrets that continue to puzzle and fascinate scientists. As we set the stage for our voyage to this distant planet, we'll delve into Neptune's position within the solar system, its size, its mass, and other basic facts that make it such an intriguing celestial body. Prepare to delve into the enigmatic world of Neptune, one of our solar system's most intriguing planets. Before we venture further, let's grasp the basic facts and figures about Neptune. Nestled within the icy outer reaches of our solar system, Neptune is the eighth and farthest known planet from the Sun. A staggering 2.8 billion miles away, it's a world of extreme cold and darkness. Now, let's talk size. Neptune is the fourth largest planet in our solar system, boasting a diameter of about 30,000 miles. That's nearly 4 times the size of Earth. Despite its size, Neptune is only the third most massive planet, coming in behind Jupiter and Saturn. Its mass is about 17 times that of Earth, weighing a hefty 1.023 sextillion kilograms. Yes, that's a real number. And yes, it's as mind-bogglingly large as it sounds. Just as Earth does, Neptune spins on its axis, but at a much faster pace. A day on Neptune lasts only about 16 hours. However, its year is a different story. Because Neptune is so far from the Sun, it takes an astonishing 165 Earth years to complete a single orbit. That's right. Since its discovery in 1846, Neptune has only completed one full orbit. Neptune's orbit is fairly circular, but it's not perfectly so. This elliptical path means that Neptune's distance from the Sun changes throughout its year. At its closest, or perihelion, Neptune is about 2.7 billion miles from the Sun. At its farthest, or aphelion, it's nearly 3 billion miles away. Understanding these basic facts and figures about Neptune helps us appreciate the sheer scale and complexity of our solar system. From its massive size to its distant orbit, Neptune is a testament to the vastness and variety of the cosmos. These numbers give us a glimpse into Neptune's grandeur, but there's much more to this distant planet. Neptune's discovery is a tale of scientific triumph filled with historical context and milestones. The story begins in the early 19th century, when scientists noticed something peculiar. Uranus, the seventh planet from the Sun, seemed to be deviating from its expected path. This sparked a mathematical race between two brilliant minds, Urbain Le Verrier of France and John Couch Adams of Britain. Both independently predicted the existence of a new planet based on these gravitational anomalies. It was Le Verrier who first persuaded Johann Gottfried Galle at the Berlin Observatory to search the night sky. On the night of September 23, 1846, Galle found Neptune, almost exactly where Le Verrier had predicted. Thus, Neptune became the first planet located through mathematical prediction rather than regular observation, marking a significant milestone in the annals of astronomy. The discovery of Neptune was not just a testament to the power of human intellect, but it also heralded a new era of space exploration. It underscored the importance of mathematics in understanding the cosmos and paved the way for future discoveries. Fast forward to the late 20th century, Neptune's first visitor from Earth arrived, the Voyager 2 spacecraft. Launched in 1977, Voyager 2 conducted a grand tour of the outer planets, reaching Neptune in August of 1989. During its flyby, the spacecraft revealed a dynamic world of high-speed winds, dark spots, and a system of faint rings and diverse moons. Voyager 2's data has been instrumental in our understanding of Neptune, but our journey of discovery did not end there. Ground-based and space telescopes, such as the Hubble Space Telescope, have continued to monitor Neptune, unveiling more of its mysteries. These observations have led to the discovery of new moons, changes in weather patterns, and insights into its intriguing magnetic field. The exploration of Neptune has also been a catalyst for technological advancement. The immense distance to Neptune from Earth, over 4.3 billion kilometers, has pushed the limits of our spacefaring technology. It has led to the development of more advanced propulsion systems, precision navigation techniques, and sophisticated scientific instruments. The history of Neptune's discovery and exploration is one of human curiosity, ingenuity, and perseverance. From the mathematical predictions of Leverrier and Adams to the stunning images returned by Voyager 2, each milestone has expanded our understanding of the outer solar system. Our journey to Neptune has not just been about exploring a distant world. It has been a journey of self-discovery, of realizing our place in the cosmos, and of pushing the boundaries of what we thought was possible. As we continue to unravel Neptune's secrets, we are reminded of the immense potential for discovery that lies within us and the universe we inhabit. Neptune's discovery and exploration have pushed the boundaries of our knowledge and continue to inspire future missions. As we peer into the cosmos, we are left with a sense of wonder and anticipation for what future explorations of Neptune and beyond might reveal. Now, let's delve into what Neptune is made of from its atmosphere to its core. Neptune, the eighth planet from the Sun, is a world of mystery and intrigue. It's a gas giant, meaning it's primarily composed of gases rather than solid matter. When we look at Neptune, we're actually looking at its outer atmosphere, a thick layer of gas that envelops the planet. This atmosphere is primarily made up of hydrogen and helium, with a little dash of methane thrown into the mix. It's this methane that gives Neptune its striking blue color, as it absorbs red light and reflects back the blue. Now, beneath this gaseous blanket, things start to get a bit more complicated. The atmosphere gradually transitions into what we call the mantle, which is a hot, dense mixture of water, ammonia, and methane. This mantle extends about 2/3 of the way down towards the planet's core. And when I say it's hot, I mean it's really hot. We're talking temperatures that can reach up to 4,000 degrees Celsius. That's hotter than the surface of the Sun. As we journey deeper, we reach Neptune's core. It's about the size of Earth and it's composed of rock and metal. And while it's not as hot as the mantle, it's still a scorching 3,000 degrees Celsius down there. This core is surrounded by an ocean of super hot and dense fluids. The pressure here is so intense that the methane, ammonia and water break down, forming an ocean of hot, dense, electrically conductive fluid. This fluid is what generates Neptune's magnetic field. Now you might be wondering, why does all of this matter? Well, understanding the composition and structure of Neptune gives us a window into the workings of gas giants. It helps us understand how these enormous planets form and evolve over time. For example, the presence of methane in Neptune's atmosphere suggests that the planet formed further out in the solar system, where it was cold enough for this gas to condense. Moreover, studying Neptune's structure can also shed light on other more distant worlds. Many of the exoplanets we've discovered beyond our solar system are Neptune-sized gas giants. By studying Neptune, we can gain insights into these distant worlds, many of which we can't observe directly. So, as you can see, Neptune is more than just a pretty blue ball floating in the outer reaches of our solar system. It's a complex world with a rich structure and composition. It's a planet that challenges our understanding and expands our perspective of what a planet can be. Neptune's composition not only sets it apart, but also offers insights into the workings of gas giants. Neptune's weather is as fascinating as it is extreme. In the vast expanse of our solar system, Neptune's weather phenomena stand out, characterized by some of the most violent storms and fastest winds. What makes Neptune's weather so extreme, you ask? It's a combination of the planet's rapid rotation and its cold temperature. Neptune's day lasts only about 16 hours, causing an intense Coriolis effect that gives rise to high-speed winds. These winds are no gentle breezes. They whip around the planet at speeds of over 1,000 miles per hour, some of the fastest in the solar system. But it's not just wind that makes Neptune's weather fascinating. The planet is also home to a phenomenon known as the Great Dark Spot. Much like Jupiter's Great Red Spot, Neptune's Great Dark Spot is a massive storm, a high-pressure system that's roughly the size of Earth itself. This storm has winds blowing at tremendous speeds, and it's one of the longest-lasting storms in our solar system. Now, if you're imagining a storm on Earth, think again. The Great Dark Spot isn't a storm of rain and thunder, but a storm of frozen methane, whipped into a frenzy by those incredible winds. It's a sight that's as beautiful as it is terrifying, a testament to the raw power of nature on a planetary scale. But beyond their awe-inspiring spectacle, these extreme weather phenomena have significant implications for our understanding of planetary science. Neptune's weather patterns provide a unique opportunity to study the atmospheric dynamics of gas giants. The extreme conditions allow scientists to test theories and models that wouldn't be possible to examine on more temperate planets like our own. For instance, the high-speed winds provide clues about the planet's internal heat source, while the Great Dark Spot offers insight into how storms form and persist on gas giants. Understanding Neptune's unique climate also sheds light on the broader processes that govern the behavior of gas giants. The planet's cold temperature and distance from the Sun make it a laboratory for studying how solar energy influences planetary climates. Moreover, the study of Neptune's weather phenomena could also help us understand similar processes on other planets, both within and beyond our solar system. For instance, the understanding of Neptune's storm systems could potentially help us predict the behavior of similar storms on other gas giants. In conclusion, while Neptune's weather might seem alien and extreme to us, it is a crucial part of the planet's identity. It shapes the planet's appearance, influences its structure and composition, and plays a key role in its overall behavior. Understanding Neptune's climate and weather patterns helps us comprehend the dynamic nature of gas giants. It serves as a reminder that our solar system is a place of incredible diversity and extreme conditions, a place where nature's power is on full display. And by studying and learning from these extreme conditions, we can gain a deeper understanding of the universe that we are a part of. Neptune's moons and rings are a testament to the planet's diversity and complexity. The gas giant is home to a fascinating moon system that includes 14 known moons, each with its unique characteristics and mysteries. The most famous of these moons, Triton, is a marvel in its own right. This icy moon is the only large moon in our solar system that orbits in the opposite direction to its planet's rotation, a phenomenon known as a retrograde orbit. Triton's surface is dotted with geysers that spew nitrogen gas, contributing to its thin atmosphere. This moon is one of the coldest places in the solar system, with temperatures dropping to around -400 degrees Fahrenheit. Neptune's second largest moon, Nereid, also has its peculiarities. It has one of the most eccentric orbits of any moon in the solar system, meaning its distance from Neptune varies dramatically during its orbit. Now let's shift our gaze from Neptune's moons to its rings. Yes, you heard it right. Neptune, like its fellow gas giants Saturn and Uranus, has rings. These rings are made up of tiny particles of ice and rock, coated with a layer of organic material that gives them a dark red hue. There are 5 main rings in Neptune's ring system: Gale, Leverrier, Lassell, Arago and Adams. Each of these rings was named after an astronomer who made significant contributions to the study of Neptune. The outermost ring, Adams, is notable for its bright arcs. These are areas where the material in the ring is densely packed, and they remain one of the most intriguing mysteries of Neptune's ring system. The formation of Neptune's rings is still a topic of debate among scientists. Some theories propose that the rings could have been formed from the remnants of a moon that was shattered by a comet or asteroid. Others suggest that the rings could be the result of material ejected from the moons themselves. The rings and moons of Neptune are more than just beautiful celestial bodies. They offer scientists a wealth of information about the planet's history and evolution. The peculiar orbit of Triton, for instance, suggests that it might have been a dwarf planet that was captured by Neptune's gravity. The study of Neptune's rings can also provide insights into the processes that lead to the formation of planetary rings. The study of these celestial bodies can also have broader implications. For instance, understanding the dynamics of Neptune's moon system could help scientists model the behavior of exoplanets and their potential moons in other solar systems. The study of Neptune's rings could shed light on the formation and evolution of our own solar system. These celestial bodies not only add to Neptune's beauty, but also offer invaluable scientific data. So, as we gaze upon the distant blue dot that is Neptune, let's appreciate not only its striking appearance, but also the wealth of knowledge it offers about our place in the cosmos. Neptune's magnetic field is a cosmic force that shapes its environment. This invisible force field, generated deep within the planet's core, is a fascinating aspect of Neptune's complex makeup. Neptune's magnetic field is a bit of an oddball. Unlike Earth's magnetic field, which aligns closely with our planet's rotation axis, Neptune's magnetic field is tilted at a staggering 47 degrees from the planet's rotation axis. Additionally, the magnetic field center is offset from the planet's center by a whopping 13% of Neptune's radius. Imagine a bar magnet not at the planet's core, but shifted towards one side. This odd alignment and offset create a magnetic field that's highly complex and dramatically different from our own. It's a bit like a cosmic game of pinball, with charged particles bouncing around in unexpected ways. This magnetic field doesn't just hang around Neptune, it extends out into space, creating a vast magnetosphere. This magnetosphere is a protective bubble that shields Neptune from solar wind, the stream of charged particles emanating from the Sun. But this protective bubble isn't static, it's dynamic and ever-changing. As Neptune orbits the Sun, the solar wind pressure changes, causing the shape and size of the magnetosphere to fluctuate. At times, the magnetosphere stretches out into a long tail on the side away from the Sun, extending millions of kilometers into space. This interaction between Neptune's magnetic field and the solar wind has some pretty cool effects. For starters, it creates auroras, much like the northern and southern lights we see on Earth. But Neptune's auroras are a bit different. Due to the planet's strong magnetic field and its tilt, these auroras can appear at lower latitudes and occur over wide areas of the planet. The magnetic field also influences Neptune's moons and rings. It traps charged particles from the solar wind and Neptune's atmosphere, creating intense radiation belts. These belts can affect the surfaces of Neptune's moons, changing their color and composition. And let's not forget Neptune's rings. While not as famous or as extensive as Saturn's, Neptune's rings are still a sight to behold. These rings are made up of dust and small particles, which are charged and can be affected by Neptune's magnetic field. So you see, Neptune's magnetic field is not just an abstract concept. It's a real, tangible force that shapes the planet and its surroundings, from its atmosphere to its moons and rings. And understanding this magnetic field isn't just about satisfying our curiosity. It's crucial for planning future space missions to Neptune and for better understanding other planets with magnetic fields. This magnetic field is another piece in the puzzle of understanding Neptune and its place in our solar system. From the auroras that light up its skies to the radiation belts that surround it, every aspect of Neptune's magnetic field adds to the story of this fascinating planet. The exploration of Neptune is a journey that continues to evolve. From the earliest ground-based observations to the first and only spacecraft flyby of Neptune by Voyager 2, each mission has brought us closer to understanding this distant, icy giant. Our exploration of Neptune truly began in 1979 when Voyager 2 embarked on its grand tour of the outer planets. With the aid of gravity assists from Jupiter and Saturn, the spacecraft reached Neptune in August of 1989, providing us with our first close-up views of the planet. Voyager 2's discoveries were profound, revealing Neptune's turbulent weather, its complex system of moons and rings, and its intriguing magnetic field. While Voyager 2's flyby was a milestone in space exploration, it was just the beginning of our journey to understand Neptune. Since the late 20th century, ground-based telescopes and space-based observatories, such as the Hubble Space Telescope, have continued to monitor Neptune, providing valuable long-term data on the planet's atmospheric dynamics and its moon system. However, these observations from afar can only take us so far. To truly unravel Neptune's mysteries, we need to return with more advanced technology and more focused objectives. And that's exactly what the future holds. Several space agencies around the world have proposed missions to Neptune designed to further our understanding of this distant world. One such mission concept, known as the Neptune Odyssey, aims to send an orbiter and a probe to Neptune. The orbiter would study the planet and its moons from a distance, while the probe would plunge into Neptune's atmosphere, collecting data on its composition, temperature, and pressure. Another ambitious mission concept, the Trident mission, focuses on Neptune's largest moon, Triton. Believed to be a captured Kuiper Belt object, Triton is geologically active and might even harbour a subsurface ocean. Trident aims to fly by Triton, mapping its surface, studying its geology, and searching for signs of a hidden ocean. These future missions to Neptune are not just about the planet itself, but about deepening our understanding of our solar system and beyond. Neptune is a representative of ice giants, a class of planets that are common in our galaxy. By studying Neptune, we can gain insights into these distant exoplanets, their potential for habitability, and the processes of planetary formation and evolution. And so our journey to Neptune continues. With every mission, we inch closer to unraveling Neptune's mysteries and advancing our knowledge of the cosmos. Each step we take towards Neptune brings us one step closer to understanding our place in the universe, to answering the fundamental questions that have driven humanity's curiosity for millennia. Understanding Neptune also involves contrasting it with its fellow gas giants, Jupiter, Saturn, and Uranus. This comparison not only highlights the unique characteristics of each planet, but also provides valuable insights into the processes of planetary formation and evolution. Let's start with the largest, Jupiter, a gargantuan world known for its great red spot. Despite its size, Jupiter is less dense than Neptune. This is due to its composition, primarily made up of hydrogen and helium. In contrast, Neptune, though smaller, is denser with a higher proportion of heavier elements like water, ammonia, and methane. This difference in composition suggests different formation processes and origins for these planets. Next, we have Saturn, the ringed beauty of our solar system. Saturn, like Jupiter, is primarily composed of hydrogen and helium, making it less dense than Neptune. But what sets Saturn apart from Neptune is its extensive ring system, the most elaborate in our solar system. Neptune's rings, though intriguing, are faint and less extensive. The disparities in their ring systems reflect the unique histories and environmental conditions of these two planets. Then there's Uranus, Neptune's near twin in terms of size and composition. Both planets are often categorized as ice giants due to the abundance of heavier, volatile substances, sometimes referred to as ices. Despite their similarities, Neptune and Uranus exhibit significant differences, particularly in their magnetic fields and climate. Neptune's magnetic field, for instance, is about 27 times more powerful than that of Uranus. This suggests variations in their internal structures and dynamo-generating processes. In terms of climate, Neptune, despite being farther from the Sun than Uranus, has the most extreme weather conditions among the gas giants. Its winds are the fastest in the solar system, reaching speeds of over 2,000 kilometers per hour. In contrast, Uranus has a relatively mild climate, with winds that are significantly slower. This discrepancy in weather patterns raises intriguing questions about the atmospheric dynamics and energy sources of these two similar yet distinct planets. By comparing Neptune with Jupiter, Saturn, and Uranus, we can better appreciate the diversity of our solar system. Each planet, despite being categorized under the same gas giant label, carries its unique characteristics and mysteries. These differences provide clues to their individual formation histories and evolutionary paths, helping us piece together the complex puzzle of our solar system's past. Understanding these distinctions is not just about cataloging planetary facts. It's about piecing together the story of our solar system, understanding where it's been and perhaps where it's going. It's about appreciating the grand tapestry of celestial bodies, each thread unique, yet all intertwined in the cosmic dance of the cosmos. Comparing these gas giants allows us to appreciate their unique characteristics and the diversity of our solar system. The study of Neptune holds immense theoretical and practical implications. This isn't a statement we make lightly. When we examine Neptune, we're not just studying a distant icy planet in our solar system. We're unlocking secrets that help us understand the universe at large. Let's consider exoplanets, for instance. These are planets located outside our solar system, orbiting around stars other than our Sun. The study of Neptune, a gas giant with conditions unlike those on Earth, provides valuable insights into these mysterious celestial bodies. By understanding Neptune's atmospheric composition, weather patterns, and magnetic fields, we're building a template that aids in deciphering the nature of exoplanets. This is particularly relevant for gas exoplanets, which are similar in composition to Neptune. Indeed, the more we understand about Neptune, the more prepared we are to recognize and interpret the signs of life or habitability on distant exoplanets. Each discovery, each observation, each mission that brings us closer to Neptune also brings us one step closer to answering that age-old question: are we alone in the universe? But the implications of studying Neptune aren't only about looking outward. They're also about looking inward into the very fabric of scientific knowledge and understanding. Neptune is a natural laboratory, a place where theories and models are put to the test. For instance, Neptune's irregular and tilted magnetic field challenges our understanding of planetary magnetism. It's a puzzle that could lead to breakthroughs in physics. Similarly, Neptune's extreme weather phenomena, like its supersonic winds and the Great Dark Spot, a cyclone the size of Earth, push the limits of our meteorological understanding. And let's not forget about Neptune's moon Triton, which orbits in the opposite direction to the planet's rotation. This unusual behavior could redefine our theories about how moon systems develop and evolve. In essence, Neptune is a treasure trove of mysteries waiting to be solved. Each solution has the potential to spark scientific breakthroughs, not just in astronomy, but in physics, meteorology, and other fields. Moreover, the exploration of Neptune has practical implications too. The technologies developed for space missions often find applications here on Earth. From advancements in robotics and artificial intelligence to improvements in imaging technologies and materials science, the ripple effects of space exploration are far-reaching. And let's not overlook the inspiration factor. The study of Neptune, the furthest planet visible to the naked eye from Earth, symbolizes the human pursuit of knowledge and exploration. It inspires future generations to dream, to dare, and to push the boundaries of the known world. Neptune continues to inspire us, pushing the boundaries of our knowledge and imagination. As we delve deeper into the mysteries of this distant planet, who knows what new horizons we'll uncover? And as we continue to learn and grow, perhaps we'll find that the answers to our most profound questions lie not just in the world around us, but in the stars above. As we conclude our journey, let's reflect on the key insights and discoveries about Neptune. This distant planet, nestled in the outer reaches of our solar system, is truly a marvel of cosmic proportions. We've explored its position and orbit, delved into its basic facts and figures, and pondered its discovery and history. From the initial sighting by Galileo to its formal discovery in the 19th century and the subsequent explorations by Voyager 2, Neptune has continued to unveil its secrets. Its complex composition of hydrogen, helium, methane, and more, coupled with its layered structure of core, mantle, and atmosphere, offers us a glimpse into the workings of gas giants. Neptune's extreme weather phenomena, such as the Great Dark Spot and high-speed winds, have given us an understanding of its unique climate and its implications for planetary science. And let's not forget its diverse moon system, including Triton and Nereid, and its intriguing rings that add to its celestial charm. Neptune's magnetic field, another fascinating aspect, has shown us how it interacts with the surrounding environment and influences cosmic phenomena. And as we look into the future, the prospect of new missions and explorations promises to advance our knowledge of this distant planet. By contrasting Neptune with other gas giants like Jupiter, Saturn, and Uranus, we've gained insights into planetary formation and evolution, and its study has opened avenues for understanding exoplanets and distant celestial bodies, potentially leading to future discoveries and scientific breakthroughs. Our journey to Neptune has surely been an enlightening one, but remember, this is just a glimpse into the vastness of the cosmos. There's always more to discover, more to learn, and more to marvel at. So let's continue to explore, to question, to ponder, and to dream. If you enjoyed this journey through the cosmos, please give this video a like and subscribe to Stellar Science for more fascinating insights into our universe. Neptune remains a symbol of the vastness and mystery of the cosmos, a reminder that there's always more to discover. Until next time, keep exploring, and remember, the universe is in your hands.